Good day, students. Welcome to part one of a series on chain rule. Here, you're going to get to sharpen your skills on the process of differentiating composite functions with the chain rule. Okay, so let's write down the instruction for the examples we're going to do. So find the derivative of the following functions. Okay, the derivative of the following functions. Alright, so number one, we have the function y equals 3 times the square root of 3x plus 4x squared. Okay? Now, let's take a look at this. Ignoring this multiple here, this is a composition of a radical function and a polynomial function. Okay? You have a polynomial function as the input of a radical function. Alright, so to differentiate, I don't want to use a radical rule, so I like to rewrite this function in a way that makes me use an easy rule to find the derivative. Okay, so what I'm going to do is I'm going to rewrite this function in the following way. I'm going to write it as y equals 3 times the quantity 3x plus 4x squared raised to the 1/2 power. Okay, expressing it like this, I can simply make use of the power rule, which is easier to remember to find the derivative of the outer function. Okay, so let's go ahead and differentiate. We're going to have the y dx equals 3. Now we're going to apply the chain rule. We're going to differentiate the outer function. If you want to look at the outer function, ignore the interior. You can view the interior as a variable u. Let's say u to the 1/2. And then, if I want to find the derivative of this, so let's say u to the 1/2 prime, I can simply use the power rule. So I'm going to bring the power to the front. 1/2 has the coefficient u to the 1/2 minus 1. So it's going to be 1/2 u to the negative 1/2. Okay. All right. So I'm going to apply that idea here. So the derivative of this function is going to become 1/2 times. Notice I'm holding the u. U is 3x plus 4x squared. I'm not touching this inner function, the one in green. I'm just focusing my attention on the outer function. Okay, so I'm going to subtract 1 from this power, so we have 1/2 minus 1. That's the derivative of the outer function. I will now multiply this by the derivative of the inner function. So the inner function is 3x plus 4x squared prime. Okay, prime is the same thing as the derivative. All right, let's move along. So here, let's simplify this side and then differentiate this. The derivative is going to be 3 over 2 times 3x plus 4x squared. 1/2 minus 1 is negative 1/2. And then we use term by term differentiation for this polynomial function here. The derivative of 3x is just 3. Plus the derivative of 4x squared multiplied 2 by 4, which is 8. And then subtract 1 from that power, 8x to the 1, which is just 8x. Okay? All right. Now, let's simplify, rewrite this. So this is going to become 3. Using the law of exponents, this can become a denominator, right? So 3 over 2 times 1 over 3x plus 4x squared raised to the positive 1/2 times, we can use the commutative property of addition. We can write this as 8x plus 3. Alright? And then finally, we can multiply across, just we can put over 1. We're going to have in the numerator 3 times 8x plus 3. Alright? Divided by, in the denominator, 2 times the square root of 4x squared plus 3x. Utilizing the reflexive property of addition, the order of addition doesn't really matter, so I just switch these two around. So there goes your derivative of your function. So this is basically dy dx. Okay? Alright. Okay, now let's move along to question number 2. So for question 2, we have the position function s, which equals sine 5 pi t plus 3 cosine 5 pi t. Okay? Alright, now we notice that we have a sum of two composite functions. This is a trig function composed with a linear function. Same story here. So we're going to differentiate these using the chain rule, okay? So the independent variable is t in this case, and the dependent variable is s. So we're going to be computing the s dt. The s dt equals the derivative of the outer function is the derivative of sine. The derivative of sine is cosine. So if I differentiate the outer function, I'm going to have cosine of the inner function stays the same, 5 pi t, all right, times, now we have to differentiate the inner function, 5 pi t, 5 pi t prime. I'll do that in the next step, all right? So same approach for this side, plus we can factor out the 3 using the constant multiple rule, factor out the 3, and then differentiate cosine. The derivative of cosine is negative sine of the inner function. You hold the inner function fixed, which is 5 pi t. The linear function 5 pi t stays fixed, times the derivative of the inner function, which is 5 pi t prime. Okay, 5 pi t prime. Prime means the derivative. Alright, so let's go ahead and find the derivative of the inner function. So it's going to give us the derivative of 5 pi t is just 5 pi, because this is t to the 1, and when you differentiate t you just get 1. So we can bring the 5 pi to the front. We have 5 pi cosine 5 pi t, and then you can multiply this minus and this plus, you have minus. Now differentiate 5 pi t, the derivative of 5 pi t is 5 pi. So when I multiply that by 3, I have 15 pi, 15 pi sine 5 pi t. Okay? Now, this is an answer, but I can also factor out 5 pi from both of them, so I can factor out 5 pi, which leaves me with 5 pi cosine 5 pi t minus 3 sine 5 pi t. Okay, so there goes the derivative of the function, the sdt. All right, now with that in mind, let's move along to question number 3. Question 3, we have the function, number 3, we have the function y equals x cosine x divided by the square root of 2x squared plus 3. Okay, so for this one I can use a quotient rule, or I can use a product rule. So for this one I like to use the product rules because it's much easier. So is there a way I can rewrite this so I can use the product rule? Absolutely. I can write this as y equals x cosine x, right, times multiplied by the square root of 2x squared plus 3 can be rewritten as, I'm writing this in blue, it's going to be times 2x squared plus 3 raised to the negative 1/2. Okay, now how did that happen? Because we can rewrite this as x cosine x over 2x squared plus 3 raised to the 1/2. So if I send the denominator to the numerator, I change the sign of the power to a negative. Okay, so this is exactly the same as this. You have the negative 1/2 just because I reciprocated it to the top, and then I change the square root into 1/2. All right, so writing it in this form enables me to use the product rule. So what is the product rule? Well, the product rule is uv prime equals u times v prime plus v times u prime. All right, there you have it. All right, so what I'm going to do is I'm going to find u and v prime, noting the fact that this first function right here is my u, and this second function right here, this radical function right here, is my v. All right, so let's find the derivatives. So first we have u equals x cosine x. So that tells me that u prime, we have to use the product rule here again. In this case, this is u, and this is v. So u is x and v is cosine x. So using the product rule, we're going to have u v prime, which is x times the derivative of cosine is negative sine x. So that's u v prime plus v u prime, which is cosine x, is v. U prime is the derivative of x, which is just 1. Alright? Now v is the quantity 2x squared plus 3 raised to the negative 1/2. Now v prime, we're going to have to use the chain rule here because we have a polynomial function inside a reciprocal of a radical function. So v prime is going to be, we use a power rule first, like we did before, negative 1/2 times 2x squared plus 3 as the inner function times the inner function, which is 2x squared plus 3, 2x squared plus 3 prime. Okay? First of all, hold the inner function fixed and then times the derivative of the inner function. Alright, so negative 1/2. Also, you subtract 1 from that power, so you have negative 3/2 as a power for this first term. Alright, so I'm using the rule x to the n prime is basically n x to the n minus 1, the power rule. That's what I applied to this function to get this. Alright, so let's continue finding v prime. So this becomes negative 1 divided by 2 times 2x squared plus 3 to the 3/2. Notice I reciprocated it because we have a negative here. And the derivative of 2x squared is simply 4x. Because if you differentiate this, you multiply 2 times 2, which is 4, subtract 1 is x, derivative of 3 is 0. Alright, now let's simplify it a little bit further. You notice 2 goes here 1, 2 goes here 2. So the v prime is going to be negative 2x divided by 2x squared plus 3 raised to the 3/2. Alright, now we have u prime, v, and v prime, so we're going to put it in here to find dy dx, okay? So dy dx is going to be u v prime, so u is x cosine x. So u v prime is negative 2x over 2x squared plus 3 raised to the 3/2. That's u v prime plus v u prime. V is 2x squared plus 3 raised to the negative 1/2 times u prime is negative x sine x plus cosine x. Okay, so there you have it. Now let me put a partition down here so we don't get our work confused. So break it down like this. Alright, so let's continue. We're looking for dy dx. Now let's simplify them term by term. So in the first two, let's deal with this product right here. So we're going to have dy dx is going to be negative 2x squared cosine x divided by 2x squared plus 3 raised to the 3/2. And then over here, this has a negative exponent, so it goes to the denominator. So it's going to be plus negative x sine x plus cosine x divided by 2x squared plus 3 raised to the 1/2. Okay? Now, what's the LCD here? What is the LCD of these two fractions? Well, this is raised to the 1/2 power, it's raised to the 3/2 power. So, in order to find LCD, I just need to find what do I multiply this by to make the power 3/2. So let's say you have u to the 3/2 and u to the 1/2. U to the 3/2 is the same thing as u times u to the 1/2, right? So if I multiply u to the 1/2 by u to the 1, that is going to give me the LCD I desire, which is u to the 3/2. Okay? So this is like $1.50. This is like 50 cents. So to make this $1.50, I just need to add $1. or 2x squared plus 3 raised to the first power. Okay? So to find the LCD of these two, I'll just multiply the right term here by 2x squared plus 3 to the first. Top and bottom. Why did I do that? Because when I combine these two, I'll get exactly that. Alright? So this becomes negative 2x squared cosine x over 2x squared plus 3 raised to 3 over 2. And then on the top here, we can just start distributing, okay? To distribute, we're going to do first, outer, inner, and then last, okay? So let's go ahead and make that distribution. So we're going to have plus negative 2x to the third sine x to the first, and then outer minus 3x sine x. Okay, I just did my first outer. Now I'm going to do my inner. So for inner, I'm going to have plus 2x squared cosine x. And then last, I'll have plus 3 cosine x. Okay? Alright, that whole thing divided by the denominator, which is what you get when you combine those two powers. If you combine 1/2 and 1, it's simply going to be identical to the denominator on the left. And this is not a coincidence, it's by design, right? Because we're looking for the LCD, we wanted the denominators to be the same, and they are. Alright? Okay, now let's go ahead and combine these two. We'll combine them together. We're going to have negative 2x squared cosine x minus 2x to the third sine x minus 3x sine x plus 2x squared cosine x plus 3 cosine x, and this whole story divided by the quantity 2x squared plus 3 raised to the 3/2. Okay? Now if you notice, this 2x squared cosine x and this 2x squared cosine x are opposites, so they cancel each other out. So we're going to be left with the final answer. Let's write cosine first. So we can write it as 3 cosine x minus 2x to the third sine x minus 3x sine x. And this whole story divided by the quantity 2x squared plus 3 raised to the 3/2 power. Okay? So there you go. There goes the derivative of the function dy dx is equal to this. Alright, so let me box it for you. Like that. Okay? There you have it. Alright, so thanks so much for taking the time to watch this video. Please subscribe to my channel so you can get future updates to subsequent parts of the series on chain rule differentiation. You can subscribe, share this video with your friends on Facebook or Twitter. More collection of clips can be found on mathgridserve.com. You can also follow me on Twitter at mathgridserve1. You can request free math help, and I'll try my best to help you. Okay? So thanks again, and have a wonderful day.